Hi guys, so in this lecture we'll be talking about diastereomers. So let me first write on the heading. Okay, so we have diastereomers, stereomers. Okay, this is E here, diastereomers. Okay, so diastereomers are stereoisomers which are not mirror images of each other. Okay, so stereoisomers which are not mirror images of each other. Okay, and another way of saying the same thing is stereoisomers which are not enantiomers are automatically diastereomers. Stereoisomers which are not enantiomers. Why? Because enantiomers are the stereoisomers which are mirror images of each other. Hence stereoisomers which are not enantiomers are diastereomers. Okay, so let us understand this with the help of examples. We have CS3, Br, Cl, CS3, H and H here, and another Fisher projection can be Br, H, HCl and CS3. These two stereoisomers are not mirror images of each other, hence they are diastereomers. Okay, so let us look at some more example. We have this one and this one. So as you can see that they are not mirror images of each other, hence these are diastereomers. Okay, so diastereomers actually have different physical and chemical properties, unlike conformers. So diastereomers have different physical and chemical properties. Okay, so let us take an example. So if we have something like this, FCli, and we change odd pair of groups and even pair of groups, then if you change the odd pair, then obviously the configuration of this is, for now the configuration of this is the highest priority, this is the second priority, so this is clockwise, but F is on the least priority atom is on horizontal line, so hence this the configuration of this would be S. So if you change the odd pair it would be R, and if you change the even pair it would be remaining the same. So this was the configuration how we get with one chiral center. Now suppose if we have two chiral centers, so in this case we would have something like, and let's say A, B, C, D are the stereoisomers which we got from two chiral centers. Okay, so let us draw a table to understand this. We have something like A, B, C, D. Okay, so A can be actually R, B can be S, similarly C can be R, D can be S, A can be R, B can be S, C can be S, and D can be R. Okay, so in this example there are more such possibilities, but for now the enantiomers would be obviously AB and CD, and obviously diastereomers, some of the diastereomers can be AC, AD, BC and BD. Okay, so I hope you are following this till now. So let us do some exercises on the concepts. So exercises, you have been given compounds, okay, and you have to identify the enantiomers, or better make it a slide congested only. You have to identify enantiomers. We have H and H here. So this is the first, this is the second, this is the third. So what all compounds are enantiomers in this? Obviously second and third are enantiomers because they are mirror images of each other. What all are diastereomers? 1, 2 and 1, 3 are diastereomers. Okay, let's look at second example. We have ClH here and HCl here. We have HCl here and ClH here, and thirdly we have HCl here and HCl here. So this is the first, this is the second, and this is the third. So let us define what all are enantiomers. Clearly 1 and 2 are enantiomers, and what are diastereomers? Okay, to maintain the continuity, let us call these compounds as 4, 5 and 6. Okay, because they are in the set of same examples, list of examples. So 4, 5 and 6. So what all are enantiomers? 4 and 5 are enantiomers, and diastereomers the remaining groups, remaining pairs, 4, 6 and 5, 6. Okay, let us do the same exercise for this case. We have F Cl Bri, we have Br F I Cl, and we have Cl, oh sorry, I Cl Brf, Cl Br and F here. Okay, so let us mark these compounds as 7, 8, 9. Okay, so are there enantiomers, are there diastereomers, what are they? So if you compare 7 and 8, so if you just actually rotate these compounds across the chiral center, then you can actually see that they are means different groups, but they are actually very much identical. How? You can see from, if I actually, how can I convert this into this? So actually if you change the odd pairs here, so if you change I and Cl here and Br and F here, so you will get the same compound as this one. So because you are changing even pair to get 8 from 7, the configuration would still be the same, right? And from 8 to 9, how do I get from 8 to 9? Simply you just exchange I and Br here and Cl and F here. Okay, so when you exchange actually Br and F here and I and Cl here, you get the same compound as 8th one, and on 8th one if you exchange Br and I and F and Cl, you get even number from 8 to 9. So you are getting the same number, same compound, so 7, 8 8 9 and 7 9 all are identical. Okay, so this brings us to the end of this lecture. In the next lecture we'll be continuing on the same example, and then next we'll be seeing some more examples of the same. Okay, so till then, good luck and goodbye.